in converting a given expression into a CNF form. Okay. And for today's class, what we are going to see is, we are going to see what is a Horn clause. Okay. Then what is completeness of Horn clause, what is meant by entailment, what is forward and backward chaining, and then of course the last part of PPT is just a revisit to the resolution and unification. We have already seen resolution and unification. Okay. So I'll start with what is a Horn clause. Okay. So first of all, here the topic says automating the first order logic inference with generalized modus ponens. So first my question is, what is GMP, which stands for generalized modus ponens? We have actually used this GMP in all the resolution. Okay. So we are just formalizing it with an example which says that if you have A implies B, okay, that which is A implies B is what you're going to have it of the form. Okay, I'll say what is GMP first. GMP stands for generalized modus ponens. Okay, A implies B. If you have this form, so you know very well. So this has to be written as not A or B. Okay, so this is how you're going to write it. Okay, this is perfect. Then you also have something called A. So given these two statements, so you know what is the conclusion. What is the conclusion? So the conclusion is not A or B, and the second statement is A. So what would be the conclusion here? Conclusion means the goal derived is B, correct? So this is what is called as GMP. So how do you derive the goal? Based on the implication statement what you have and the other statement. So if you have a statement of this kind, A implies B, the second one is A, then you can conclude B from it. So this particular derivation is what is called as generalized modus ponens. Okay. So now, okay, we'll go through a few slides before we solve some problems on entailments. Now here, they say that entailment, first order logic has got something called as entailment. So I'll tell you what is entailment. So if they say A entails, you have a symbol for that. I'll show you that. A entails B. It means that B is true if and only if A is true, right? So the statement is true. The given statement B is true if the statement A is true. So if they say that if the true statement is false, then there is no guarantee that the procedure will determine this. That is, it may halt or it may never halt. So that is what is as far as the entailment is considered. Okay. Next, coming to GMP. Okay. Now, from what is GMP here? It simply means that you have atomic sentences and then you have a set of implication sentences, and at times this is not mandatory. Okay, if required you will go for substitution, otherwise you will not go for substitutions. Okay, so substitution is what? Renaming a particular variable. What is renaming? The other name for renaming, we have already seen it. It is also called as unification. Okay, so by using unification wherever required, you're going to derive a new sentence. So this whole thing is called as generalized modus ponens. Okay, so what is substitution? We have seen lots of example on this. This is nothing but renaming a particular variable. Say for example, here you have okay, eats of y comma x. If you also have eats of Ziggy comma ice cream, so the function names should be the same, eats. Okay, so that should be the same, in which case y can be renamed as Ziggy and x can be replaced as ice cream. So this you will apply. The other name for this substitution is nothing but unification, which is nothing but renaming a particular variable. Okay, so this is not compulsory. It doesn't mean that you have to apply it. Wherever required, you can apply it, and after applying it, you get a standardized form. That is what is called as GMP, generalized modus ponens notation. Okay, then Horn clauses. So Horn clauses simply means that a given sentence, it is called as a Horn clause if it has at most one positive literal. Got the sentence? So it simply means if you have a big sentence, I can show you an example here. or horn clause. Okay, so if you have a statement saying P1 or P2, okay, not P1 or not P2 or not P3. So you can have any number of statements like this. So the important thing is the expression should be a disjunction of literals. Okay, got it? Or I put it as Q. Okay. So the first thing what you have to observe here is the given expression should be disjunction of literals. So what is meant by disjunction of literals? It simply means that you should have only or clauses connecting the literals, right? So that is one expression. I mean, one important thing that you have to know for as far as the horn clause is concerned. Then at most one literal should be positive. So if these two conditions are satisfied, then you call the given expression as a horn clause. Okay. So when I say at most one literal should be positive, here one literal here is Q. Okay. So this literal should be positive. All the other literals here are negative. P1 is negative, P2 is negative, P3 is also negative. So if this two conditions is satisfied, then you call the given statement as a horn statement or a horn clause. Got it? Now coming to the definition here. Now you have a sentence given here. So for all x P1 and something. Okay. So now you have to check whether this is a horn clause or not. So how do you check? As usual, we have to convert the implication symbol here into, you have to remove implication. So when you remove implication, what happens? This becomes not of P1 of x or not of P2 of x or not of Pn of x or Q of x. So what happens here is actually or Q of x. So you have everything or symbol here, disjunction, and one literal is positive, which means one Q of x is positive. So in this case, all the p's here are zeros, I mean negated. Okay, so at most one of them is positive and all are of the form of disjunction of literals. P1, P2, P3, everything is disjunction of literals. So if you have a clause like this, then this is called as a horn clause. Got it? So horn clauses represent a subset of the set of some sentences representable in first order logic. So where are you going to use the horn clauses? They are nothing but a subset of the knowledge base. So whatever knowledge base you're having, one of the sentence can be a horn clause or all the sentences can be a horn clause. Okay. Now your complete knowledge base will be called as a complete. It will be called as complete if all the given sentences are horn clauses. I'll give you an example for that when we go through the next further slides. Okay. So as of now, you have to just understand only one thing. What is horn clause? Horn clause is nothing but it should have disjunction of literals, which means it should be literals. Literals means what? P, Q, all these are literals. So they should be connected by or symbol. Okay, so that is the first criteria. The second criteria here is it should be at most one literal. That is only one literal should be positive. All the other literals should be negative. Got it? So that is all about the horn clauses. What is horn clause? Okay, now the next topic. Okay, before we move on to the next topic, which is forward and backward chaining, we'll go back to a few problems and we'll check whether we can do these problems here. Okay, so the first problem here says find the complexity of the horn clauses. Okay, so here the first problem here is find the complexity of horn clauses. Okay, complexity is nothing but the number of literals in that particular horn clause. Now, first of all, check whether these clauses are horn clauses. Okay, so after you check whether these clauses are horn clauses, then check whether what is the complexity of the horn clause. Okay, so the first statement here, one literal is positive. Is it a horn clause? At least for this you have to answer. No other go. I'm not taking class only for my laptop. So A is it horn clause? You're just going to say yes or no. "31 students are here. At least one reply I expect." You stay silent, I'll also stay silent then. Until you're answering, I'm not going to continue. You're all going to get absent today. That's all. First clause is A. Is it a horn clause? That is my question. Why are you like this?
Ma'am, yes, it is a horn clause.
Okay, B.
Yes.
Okay, then the next expression here.
No.
Why no?
Because
Not A you have, or what's the reason?
because of
See, it is disjunction of
because it is the disjunction of this the negated literals.
it has to be disjunction of literals. Okay, so the first statement doesn't say that disjunction of only positive or negative literals. It just says that whatever literals you have, it should be disjuncted. So here you have a disjunction, here also you have a disjunction. Okay, so simply saying this whole thing can be treated as disjunction of literals. So the first statement is satisfied. The second one says at most one literal should be positive. So here, which is positive if you ask? The literal C is positive. Okay. So here, this statement, I mean, not A or not B or C is also horn clause only. Got it? Here,
Okay,
if you
ma'am.
see the next one, not C or D. So you just have two literals which are joined together by a disjunction, disjunction operator. So here the first one is satisfied. And at most one literal should be positive. So here what happens? The only one literal which is positive is D. Okay, so this is also a horn clause. Okay, the next one. Is this a horn clause?
Yes, ma'am.
Okay, good. Then the last one, not E or not F or G. Is this a horn clause?
Yes, ma'am.
Yes, ma'am.
Okay, perfect. So you have all the horn clauses, I mean all the given expressions as horn clauses. Now only thing, they're just asking you to calculate the complexity of the horn clauses put together. So what is complexity? It's nothing but the number of literals that is being used. Okay, so 1, 2, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so the number of literals, whether it is positive or negative, you don't have to worry about it. Complexity is the number of literals used in the horn clause expression. Okay, so which is equal to 12 in this case. Got it? So that is how you have to do the horn clause. First check whether it is horn clause. So that is the main task given to us. Now coming to the second problem, translate the expression into horn clause. So, okay, how do we do that? Not of, how do we do this? First the step is what? Converting into CNF. So when you convert it, it is going to be not of A or B. So not A or C, correct? So this is my, take this as A, take this right hand side as B. So this whole thing is going to be not A or B. So this is removal of implication, the first step. After I do this, now the next step I have to do is take the negation operator inside the bracket. So this is going to be not A or becomes what? or becomes an, when it is negated, it becomes and, correct? So I'll just pick up an and operator here. Okay, so this negation, when it is taken inside, this becomes not A and not B. Okay, so within brackets, you have taken it inside. So this brackets, I just put it here. Next, I have or C. Okay, this is my next step. Okay, now to call it as horn clause, what should I have? I should have something like disjunction variables only. I'm not supposed to have and here. So what can I do? I can apply my De Morgan's law and I can call this as not A or C. Okay, this is one statement, and where did it go? And not A, sorry, not what happened? Not B or C. Okay, so this is the application of De Morgan's law. Then what should I do? I have to remove the elimination of conjunction operation, which means what? This can be changed as, I can remove elimination operator and I can put it within curly parentheses. Okay. Now the two expressions that I have with me is not A or C. That is one expression. Then the second expression is not B or C. Now they are asking translate the expression into horn clauses, just to check whether the given two expressions are horn clauses. So the first expression here is not A or C. Is it a horn clause? Not A or C?
Yes, ma'am.
Yes, perfect. Because you have disjunction of two variables, two literals, out of which one is a positive literal. Similarly, when you have not B or C, that is also a disjunction of two literals with one literal, I mean at most one literal being a positive literal. So here this is going to be translating the expression into horn clause. So you just have to verify that the given, I mean whatever expression you have got at the towards the end is a horn clause. So with this problem is also over. Then moving on, okay, to the third statement, third problem, it simply says, is a statement given below, okay, same as the previous statement only, previous problem actually. Is the statement given below a horn clause? So how do I do this? What is the first step? Elimination of implication, correct? So if I eliminate implication, my first step, what is the resultant I get? I get not of the left hand side, not of my left hand side. So A implies B becomes not A or C. This is my first step. Then my second step is move negation inside parenthesis or move negation inside the brackets. Okay, so if I do this, what happens here is I'm going to take negation inside. So this is going to be not of A. Okay, then and becomes my or, then not of not, double negation. Okay, so double negation of B. Okay, so when I take the negation operator inside, so this is what happens, or C. Okay, next what happens? So this I can write the whole thing as remove double negation and treat it as positive little. Okay, so now what is the value I get? I get not A or B. Okay, double not becomes positive here, or C. Now this can also be written as, if you want, you can just remove these parentheses. Anyway, you have this rule which says this is the same as, okay, I can remove the parentheses, not A or B or C. This is my final result. Okay. Now this is not the question. If they ask you to simplify the given expression as a CNF, then you can stop with this. Now the question is the given statement a Horn clause? So what is the answer? Is this a Horn clause? This is the question. Yes or no?
No, ma'am.
Very good. Why?
Because it has two positive literals.
Very good. Perfect. So because since it has two positive literals, you have to just say the given expression is not a Horn clause. That's all. Okay. So this problem is also done. Then coming to the next problem. Okay, prove that. Oh, this is okay. Different problem. Forward and backward chaining. Okay, I'll move back to the PPT. Okay, so till now we have just seen what is, we know how to use all the 9 rules, whatever rules we have studied, to convert the given expression into a CNF. Okay, so from that CNF, you have to check whether the given expression is okay, of the form of a Horn clause. That is what we have seen now. Next, moving on to forward and backward chaining. Forward and backward chaining, it's very simple. You have the knowledge base given to you. Okay, so from that knowledge base, you have to derive at a given solution, or we call it as a goal. Okay, that is what is called as forward chaining. What is backward chaining? Again, you have to derive at the goal only, but then it is in the reverse direction. That is, given the facts, if you're going to derive at the goal, or given the goal, whether you're going to derive at the facts. So either of these two things, if you do, that is what is called as your forward and backward chaining. Okay, now here you have to remember only one thing. In place where you can use GMP, okay, so that is called as forward chaining, which means what? In backward chaining, you cannot use GMP. What is GMP? GMP is nothing but generalized modus ponens. Okay, so if you can do that, if you can use it to derive a goal, that is what is called as forward chaining. Okay, if you cannot use GMP at a place, then it is called as a backward chaining. And of course, the other difference is if you start from the facts and derive the goal, or if you start from the goal and derive the facts. Okay, that would be the difference between forward and backward chaining. Got it? I'll explain it with an example. Okay, so now I'll take a simple example. Here they've not proved it. Fine. I'll take one simple example. Okay. Now looking into this example, so here you have okay. Now the given sentences. So what you call it as all the how many sentences? 6 statements you have. So this 6 sentences, so they are called as the knowledge base. Okay. So whatever sentences is given to you, so those are called as your knowledge base. Okay. Now how should you start and what you should do? So initially, always you have to start with the goal. So goal must always be written on top. So when I say goal must be written on top, so actually forward chaining and backward chaining, you are just going to explain it with a small diagram. Okay. So I will start with a goal. So what is the goal here? Prove that John likes peanuts. Okay. See here, if you can see properly here. Prove that John likes peanuts. So this is going to be your goal. So where do I write this goal? I'm going to write this goal in this particular statement. So how do I write it? So use the same for syntax what is given in the facts, the knowledge base. Okay. So I can represent my goal as likes of John, comma, peanuts. Okay, before we solve the problem, you have to be very sure, or you have to have the knowledge of unification. So what is unification? Just to recall, so wherever places you have to rename, it can be renamed. Okay, say for example, here you have food of X, food of X, food of X. So okay, everywhere X only is there. Okay, any other place if you can rename. Okay, see here you have eat of X comma Y, and here you have eat of su comma X. So if required, what can be renamed? X can be renamed by this particular person called as su of X. I mean su, it can be renamed as su. So wherever you have X, it can be renamed as su. So that is what is the ultimate logic. Got it? So here you have likes, any other place? No. Right. So this is so the, remember you have to, I'll put it here. Remember you have to make use of unification wherever required. Okay, so that is a rule. Unification, or in some books it will be given as substitution. Okay. How do I copy this? Okay. Now we are going to first of all solve with the forward chaining. So I'll tell you what is forward chaining. Okay, so here you have the goal. Now when you have likes of John comma peanut, so what can be done is you just have to search for likes. So here you have likes of John comma X. So what is this? Is entailment. So what is entailment here? So this statement is true if the previous statement, that is A implies B. So B is true if A is also true. Got it? So you're just going to pick this statement, a food of X, and you're going to place it below John likes. So wherever you have entailment, you're just putting the entailment over here. So this is my goal. Okay, I'll put this as goal. Now, what is the next thing I have to do is I'm going to take the entailing statement, the predecessor of the entailment statement. So what is that? It is nothing but food of X. Okay. So between these two, you just have to draw an arrow, a line, which means this is entailment. Okay. Typically, we are going to construct an and or graph. I'll tell you how that happens. Okay. Now, food of X is there. What is the entailment of food of X? If you ask me, so where all you have in the right hand side. So that is A implies A entails B. Okay, which means food of X is true if the left hand side is true. Okay, so I have three statements here. One is apple of X, the other one is chicken of X, the other one is some other statement, eat of something, and not killed of Y. Okay, how do I represent these three statements? So one statement, apple of X, I just copy it. Okay, before that, I just copy the symbol here and I'm putting it in the left hand side. So this is one entailment. Then the second entailment is I have for food of X, which is chicken of X. So this box is for chicken of X. Then the third entailment for food of X is something else, which is eat of X comma Y and not killed of Y. So I have actually you have two boxes and okay. So if I split it, it's going to be I'm going to draw it as two different boxes. Okay, so this is one box. I'll make it short. And one more box. Okay, so here what should I add? I have to add what entails this. So the first one is for entailment apple of x. So this is true for the first box. Then for the second box it is chicken of x. Okay, and for the third box it is eat of x comma y and not killed of y. Okay, so when I draw arrows, you just have to follow that. I will put one OR graph to apple of x, then one OR graph to chicken of y, chicken of x, then one AND graph. So you have seen AND and OR graph when we have studied problem reduction methods in unit 1 or unit 2, I don't remember, just check it out. So the same thing we are doing, but then this is going to be an OR graph and this is going to be an AND graph, because here it says it is AND eat of x comma y and not killed of y. Okay, so that is what is given. Okay, now coming down, can I replace this eat of x comma y? If you ask, the answer is yes. So I can replace it with eats of bill comma peanuts. Okay, so this is the statement I have for this particular value. So here I'm actually introducing unification. So eat of, it is bill comma peanuts. Okay, and similarly here it is going to be not killed of bill. So instead of this is going to be not killed of bill. So where do I get all these from? It is given in my not killed of bill. Okay, it is given in my knowledge base. So this statement and this statement. Okay, so actually when you write this particular statement here, this is a simple A and B, right? So this simple A and B, you don't have to represent it as an AND graph here. What can be done is you can remove this and you can call this as two different statements in your knowledge base. But then here you cannot do this, right? This whole thing is going to be AND only. See, here you have not simplified, you have not done anything. Okay, just like that, you're taking the entailment, which means if it A implies B means B is true if A is true, and you're just like that drawing a graph. Okay, but here you don't have an entity, you don't have any such kind of implication. You just had an AND. So that AND, I have just replaced it into two different statements. So what is the reason of putting it as two different statements is, I'm just going to draw a line from eat of x comma y, and I'm going to draw a line from this. This is not an AND gate. Okay, just a line. So I'm going to draw a line from eat of x comma y and one more line which says not killed of. Okay, fine. Now from the goal, I have actually derived at the facts, right? So I had a goal which was likes of John comma peanuts, and here, okay, everywhere wherever you're just replacing it, you have to specify it next to the arrow itself. So here when I have something like this, I'll just say that insert this is actually not a text box. I'll make it as transparent. This is not a text box here. Just to mention that X is replaced by bill. This is mentioning unification. Okay, and Y slash peanuts. This is how I mention the unification part. Okay, so just rename it, and you don't have to put the put any box here. Next to the arrow, just write X is renamed as Bill, Y is renamed as Peanuts. This is unification applied here. Similarly, here Y is renamed as Peanuts. So the same thing can be copied and put here. But then here you don't have X at all, only Y. So in both the places, unification is done. Okay. So the okay. Now you have derived at the facts that what are the facts that is present in you. So X is renamed as Bill. Okay. So wherever you have X, you can rename it here. So chicken of Bill and apple of Bill. So food of Bill. So that can be done. But then these two things we are not using because we are not taking that anywhere into consideration to derive this goal. So the path is only goal to food of X. So from food of X, which is eat of X comma Y and not killed of Y. And this eat of X comma Y gives you the facts that eat of Bill comma Peanuts and not killed of Bill. Okay. So now if you ask me what are all the effective clauses that has been used. So the clauses that has been used are the first clause, not killed of Bill, eats of Bill. So these two were used. Okay. Then did I use this clause? Yes. So this clause is also used. Then chicken, apple, all these are not used. Then finally for food of X, likes of John, comma. Okay. So using these four clauses A, D, E, and F, right? So I have actually proved the goal, which is likes of John, comma X. Okay. So here this is the goal, and these are called as the facts. So all these 1, 2, I mean actually only 2 facts, and then this is also a fact. So using the facts, if you're deriving at the goal, that is one way of doing deriving the goal. Got it? So I just repeat, goal is specified at the top always, irrespective of whether it is forward chaining or backward chaining. Okay. So I'll go back to the definitions. Okay. So forward chaining here, you're going to have the goal at the top. Even for backward chaining, you're going to have the goal at the top. Okay. And it moves, okay, inference procedure. So what happens here is definition of forward chaining. It's an inference procedure. It moves forward from the knowledge base to the goal. Okay. So given the knowledge base, if you're deriving the goal eventually, then it is called as forward chaining. Got it? Now another way of proving it, whether it is true or not, right? So let me take this. The other thing, one more definition also I gave you. What is that definition? Before you draw this particular tree, you can also check whether this will really come out to be a proper tree or not. A crude method of doing it. Okay. So how that can be done is very simple. You just check out whether you can apply, check if you can apply GMP to the knowledge base. Okay. If this is true, okay, which means if you can apply GMP to knowledge base to derive something, then you can very well say that it is forward chaining. It means that it is forward chaining. What is forward chaining? Given all these facts, these are all facts. Okay, you have to prove John like peanuts. We'll just check whether you can get that or not. Okay, so I'll just start with the first one. So what is the first step here? Removing the implication. So quickly we'll do that. So removing implication, which means, okay, food of X. So I have to put not food of X. Not A or B. So what is B here? It is likes of John, comma X. That is my first statement. Okay. Then my second statement here is, okay, second statement is not apple of X or food of X. That is my second statement. Then third statement is not chicken of X or food of X. Okay. Then my fourth statement is, okay, if it is there exists only, I have to bother about it. Now I'm just going to take this statement here. apply a not symbol for this. Within brackets, I have my left hand side, or my right hand side is foot of x. Okay. Then my next statement. Okay. Next two statements, I'm just like that copying because it is already and that was broken down and elimination has been done. If you don't want that, if you want me to explain what step by step again, I'll just put it as the same old statement what we had, which had the terms this and, because as of now we are only eliminating the and statement and elimination is being done. Okay, so that is my next statement. Then not guild of bill. You don't have any implication, so I'm just putting it as not guild of bill. And the last statement is okay, not eat of bills of x or not eat of bill of x. Eat of bill of x, is it? Bill. Okay. So if you take this, okay, why yellow color for this? I'll just make it as white. Right. Now, what is that you can derive? So the first not food of x, if you apply GMP, right? GMP. Before that, any other rule that has to be applied? Yeah, you have to apply move negation inside. So when you move negation inside, what happens? Here you don't have to move inside. Here you don't have to move inside at this place. Okay. So when you move inside, this bracket goes off, this and becomes your or, and not of not gets cancelled. So this becomes killed of y or food of x. Okay. Then this and elimination can be done. So when I say and elimination can be done, so this and I'm going to delete it and take it into two different clauses. Okay, fine. Now if you can use GMP, what happens? Move negation inside is done actually. Now I've done both the steps in one step. Next step is check whether the clauses are not killed of bill by repeated twice. So it can be taken as only one clause. Okay, now check horn clauses. So what is meant by checking for horn clauses? The first one, is it a horn clause? Yes, it is a horn clause. The second one, it is a horn clause. The third one, it is a horn clause. Why? Because you have one negation and at least one positive literal with one disjunction. Okay. Then the fourth one, horn clause. Fifth one is also a horn clause. Why? Because you have eat of bills comma peanut, which is one positive literal. Then not killed of bill. Okay, this is not a horn clause. Not killed of bill is not a horn clause. How does it come? Not eat of bill. Okay, this is a horn clause. Anyway, so you have just a statement 6 not to be a horn clause. We'll check whether you can apply this or not. That is whether you can use GMP or not. Okay, let us randomly take statements 1 and okay, statements 3. So what is using GMP? What is the resultant you get? Using GMP, which is not food of X or food of X gets cancelled. Okay. So finally, what is the result that you get using 1 and 3? Using GMP. Okay. Using 1 and 4. So the resultant, what you get is not food of X or food of X. These two gets cancelled. So finally, you'll be having only likes of John comma X, right? Likes of John comma X, or it is going to be not eat of X comma Y. So this is the one that you get, right? Then if you take 5, so if you choose 5 and if you apply 5, what happens here? Eat of bill comma peanuts. So here you have not eat of X comma Y. So eat and not eats gets cancelled, and you have X as bill and Y as peanut. So X is renamed as bill and Y is renamed as peanuts. So here you introduce unification, and the resultant what you get here is eats and not eat gets cancelled. So finally you'll be landing up with John of X comma, John comma X. Okay, now here eat of will comma peanuts. Okay, you also have not killed of Y, right? 1 and 4 is done. So finally you have this. If you take eats of bill comma peanuts, not eats, so John comma peanuts. Okay, here this is replaced as peanuts, because here see this Y is actually representing peanuts here. So here when you replace likes of where is it? Yeah, you have to prove this. So likes of John comma X. So here this X actually means the peanuts here, because Y is renamed. Don't think that Y is renamed as peanuts, but then the second variable here is renamed as peanuts. Okay, so in that case here you have to rename it as peanuts. Okay, so using the fifth statement. So you have got the conclusion here. So the ultimate point here is, if you don't have to use all these statements, that is one thing for sure. And if you can apply GMP to resolve the given statements and derive at the conclusion, then it is called as forward chaining. That is one thing you have to keep in mind. Got it? So if you can apply generalized modus ponens, then if you can derive at the solution, you can call it as forward chaining. Okay, so what is forward chaining? Using your facts, you're going to derive the goal. Okay, so what does the facts mean? Facts means all these are facts, just the given information. And finally, you're deriving at the goal. Okay, so this is called as forward chaining. How do you do that? Using your and or graph. That is, and or graph we have already seen. It is nothing but your problem reduction method. You'll be representing the solution as and or graph. How do you do that? You take the goal, always let it be forward chaining or backward chaining. We are going to put the goal at the top. Okay, so once you put the goal at the top, so that is going to be your entailment, which means A entails B. Actually the symbol will be A vertical line, then this A entails B. So what does this mean is, it is different from implication, remember that. So when you're drawing the forward chaining graph, you have to go for entailment. So B is true if A is true. Okay, so here B is true. What is B? B is likes of John comma peanut. This statement is true if A is true. So you can put A below this. So what is A? Food of X. So here if you see the statement, likes of likes of John comma X. So this is B. What is entailing statement? It is food of X. So again, if I take, what is the next statement that I have to put? If food of X is at the is your parent, then the following statements must be either apple of X or chicken of X, or this whole thing, eat of X comma Y and not killed of Y. So since I have an and symbol here, I'm going to call this as an and graph. Okay, the other two is going to be an or graph. Then Again, this AND graph can be splitted because this eat of x comma y, here you have a separate clause which is bills comma peanut, and for not killed of y, I have something called as not killed of bill. So if I just replace these 2 points here, I'm not using all the knowledge base need not be used. So what are all the rules that or what are all the clauses that I've used? If you ask me, it's only A, D, E, and F. So using these 4 clauses, I have proved that John likes peanut. Okay, so this is how I have proved it. So this is a tree that I have constructed. Now we have one more tree for which again so this is actually what, starting from the goal you have derived at the facts. Now we'll construct one more tree. 12 o'clock. Okay, we'll construct one more tree by means of which, starting from this clauses, we will be deriving at the goal. Okay, but still that tree also will be a kind of a similar tree. We'll see how that has to be done. Okay, so with this, this is over. Probably you can try this and come next class. You'll be answering this forward chaining example. How do you derive at, this is your goal, sneeze or fleece. So simply if you check, if you can apply GMP, that is one method, or you can construct your trees using your entailment logic. We'll see this example next class. Okay, again backward chaining example. Oh, this is the to-do problem. Okay, now I'll give you a few more small topics. What is completeness of GMP? Completeness of GMP means if all the clauses given in your knowledge base, if it is true, then the goal is said to be true. Okay, simply if all these are horn clauses, quickly check if all these are horn clauses. So the first one, not P of X or Q of X, it's a horn clause. Second one, not P of X, which means P of X. P of X or R of X. So if you ask me whether this is a horn clause, no. See here you have 2 positive literals. This is not a horn clause. Then not Q of X, third clause, not Q of X or S of X, horn clause. Not R of X or S of X, again this is also a horn clause. So here it is not complete. Why? Because it is not complete, because all the knowledge base, all the statements in the knowledge base must be true, must be a horn clause. But here in this case, what happened here is the second statement is not a horn clause. Therefore, the whole knowledge base, it's said to be not complete. Okay, so that is what is called as completeness of GMP. So you should have all the clauses as horn clauses. Then moving on. Okay, these problems, resolution, refutation, and unification, we have seen many problems of this kind. So again, we are going to revisit all these problems in next class, right? So as I told you, one more thing to complete is horn clause is done, completeness of horn clause is done, entailment is also done. So what is entailment again? A entails B, which means B is true if and only if A is true. Okay, then forward and backward chaining. Okay, we'll continue next class. For your attendance, only 34%.